you'd think that all the information of that three-dimensional spherical star would be proportional to its volume. So the volume of the black hole, would actually be a measure of the information that's retained, but it's not. It's proportional to the surface area of that star, which is the spherical event horizon. Now, when that was realized, there was an aha moment, because that's what a hologram does.
Welcome to the Quantum Theory Podcast.
Thank you, Jude, so much for joining us today on the Quantum Theory Podcast. I am elated to have you on and thrilled to dive into most notably your book, The Cosmic Hologram, and really the perspective shift, paradigm shift, I would call it, that we as a species are undergoing in the present day, and that I'm personally thrilled to be alive during and be a part of. And I think you are are truly one of the great minds of our day that is really making this tangible, quantifiable, and empirical through your studies and through the work that you've put down. So before we hop too deep into things, I want to just really quickly just get some background on yourself for the audience and kind of your origin story of how all of this started for you. I know you mentioned some noetic experiences at a young age that kind of opened your mind to Indra's net and this idea very early on. And so I'd love to give the audience a little background of kind of, who is Jude and how have you arrived to where you are now in your work?
Well, Jared, thanks for that. And just to say, it's been a very scenic route. It has not been a linear journey by any stretch. And I'm very grateful for that, because along the way, I've sort of been so, I'm curious. I mean, my mum used to say that curiosity was my middle name. So from a very early age, I was just curious about the world around me. And as you mentioned, at a very early age, around 4 years old, I began to have what you refer to as noetic experiences. Some might call them supernormal experiences. But basically, I was having out-of-body experiences. I was hearing discarnate voices in my inner hearing. I was seeing sort of auras. So the whole panoply arrayed before me of worlds that were not what it appeared the folks around me were experiencing. I didn't realize that to begin with. It was only over time that I sort of realized that other folks didn't seem to be experiencing this. And it wasn't because I was special. It really wasn't. What I did realize is by not sharing what I was experiencing, just having too much fun, actually, I didn't share them with anyone until I was much, much older. So nobody around me said, oh, that's nonsense, or that's just imagination. So I just carried on with this noetic, supernormal, walking between worlds experiences, which has been a lifetime, every day.
Wow.
Still. So that really was my beginning and my journey and my ongoing exploration. So in a way, I'm so grateful for that, because I grew up the granddaughter of coal miners in the north of England. So very sort of modest upbringing, very practical upbringing. And here was I, not telling many folks about it, but heading off into the stars and beyond.
Wow.
But what it did was it also, the curiosity was about, well, how was what I was experiencing bridging to this world and what I was being taught at school? And actually, what I was being taught at school was the paradigm of a world of materialism and separation, very practical, very mechanistic. And even when I went to university at Oxford and studied quantum physics and relativity physics and cosmology, they were giving deep clues into what I'd been experiencing from childhood. But do you know, for me, the most comforting, validating sources were the ancient traditions, the universal wisdom traditions, and especially that of ancient India, the Vedic tradition of ancient India, because that was saying, I was reading from a very early age that mind and consciousness aren't something we have, they're what we and the whole world are. That is in the Upanishads. That is in the Ishnavaya Upanishad, the Bhagavad Gita. And I thought, yes, this is how I'm experiencing the world. So that really gave me, I think, the sort of the vote to keep on going. And so the whole journey has been that continuation of exploration. And now, as you say, I think we are in this pivotal threshold moment where we have so much evidence that's coming forward that's converging with universal wisdom teachings and indigenous traditions to literally turn that old paradigm of materialism and separation on its head.
I absolutely love that. Thank you so much for sharing. And that is the mission of the Quantum Theory podcast, to converge science and spirituality in those Eastern wisdom traditions. And I love everything about what you just said. And it's interesting. I feel that the thinkers such as yourself who have kind of gone down this road have a foundation of experience. If you're familiar with Federico Fagin, his story is now pretty prominent.
I am.
Okay. Yes. So I feel as though there are these, there's sort of a foundation of first-hand experience that gives sort of the direct, I guess, window into that world, and then you can then start connecting the dots into the actual science that's now emerging, and so. I'd love just to kind of set the stage here, because you mentioned it, really where we are with the divide of materialism and more of the oneness type of perspective, cosmic mind, consciousness being fundamental, even theories like idealism and things of the sort. Where are we right now, and what is the key divide between these two worlds?
Well, I think, first of all, there are a lot of scientists who, of course, were trained in a paradigm which is actually a mechanistic paradigm that goes back to mid-19th century, before quantum physics, before relativity physics. But that paradigm was not just powerful in a scientific perspective, it was very powerful because it drove the Industrial Revolution. So all that's come forward really since then, in terms of the way we educate our children, the way we govern ourselves, structures, organizations, they're all really based on this mechanistic worldview. And of course, it's a worldview that is essentially meaningless and purposeless.
Right.
And, where consciousness was always a great mystery, but was always assumed to be just human consciousness or a bit more beyond that, and somehow emerged through random, accidental evolutionary processes. So that's really what you and I would have inherited at school, certainly me, and those of my age. That's what we were taught at school. And the point is that even the breakthroughs of quantum physics and relativity physics, they gave us clues. They gave us profound clues that the world is not made of separate stuff, that it is about profound interrelatedness. And to work at all, as you're probably aware, quantum physics requires the entire universe to be non-locally unified. And you're almost certainly aware too that for decades in the late 1980s and through into the 2018, it was finally able to experimentally show, by entangling photons of light in a lab with starlight from 600 light years away, and a whole cascade of entanglement triggered by light from a quasar, a very active galactic center, 12.2 billion light years away. In 2018, that took this experimentally to cosmological levels. And that was so compelling that in 2022, the Nobel Prize for Physics was given for universal non-locality, in other words, a unitive universe. And, Einstein didn't get the Nobel Prize for relativity because it was seen as being too contentious. He actually got it for the photoelectric effect. So what this is showing, that this is settled science. Now, alongside all of this, over the last sort of 20 years, perhaps a little more, but certainly in the last few years, we've had more and more and more evidence at all scales of existence across numerous fields of research that are all showing the same thing. that our universe essentially meaningfully exists and purposefully evolves as a non-locally unitive entity. What is really important, I think, for the scientists who have been struggling with this, because I think most cosmologists are sort of pretty much over the bridge now, because they realize that we cannot understand the appearance of our universe, its energy, matter, and space-time. From that level, we have to go deeper. So just as science has always done, it includes and transcends. Just as quantum physics did to Newtonian physics and relativity physics did, it included and transcended. We're now in a place of inclusion and transcendence, but we can only do that by realizing that mind and consciousness, like the Vedic tradition showed us, aren't something we have, they're what we and the whole world are. So we're now at this point where we can expand our perception in an incredible way that goes way beyond science. And it's still accessible to science, because the reason we're able to go to this place, and I could write the Cosmic Hologram, is that all the evidence was showing that if we look deeper beneath the appearance of our universe, we start getting answers to how that appearance comes about. But for me, more importantly, and going back to my lifelong journey, we also have a deeper understanding of why our universe is as it is.
Well, that was profound, and thank you so much for sharing that. I think that's a great segue into a bit more of the meat and potatoes here of the mechanism, and then jumping into some of these different aspects of your work that you pointed out. And one of the things is, speaking of entanglement, and I think there's a big bridge when we're talking about, well, number one is going to be wave function collapse, right?
Yeah.
And then we have sort of, as you said, really coming to grips with what entanglement means. You know, we can measure it, we can understand it, we can give a Nobel Prize, but then there's that next step of okay, so what does this actually implicate here? And I think what's really interesting, as you pointed out, is it works on macroscopic scales. We have things as large as diamond studs that we are able to actually entangle. So what are the implications of entanglement on a macroscopic scale?
Okay, well, absolutely. I mean, certainly at the level of organic molecules, we can entangle those now. But the experiment that I mentioned in 2018 was only entangling photons, but it was doing it at cosmological scales. In other words, there was sort of photons of light in a laboratory that were then entangled with starlight coming down a telescope, but emanated 600 light years away. But the whole, what's called a cascade of entanglement, which far surpassed something called the Bell's limit. And the Bell's theorem was way back a recognition of the need for universal. Our whole universe needed to be entangled for quantum mechanics to work at all, because that cascade, which passed all of the thresholds, was triggered by light from a quasar 12.2 billion light years ago. That was so beyond any dispute that, you know, what we're talking about is universal non-locality, is universal entanglement. The issue was, for a long time, the fact that it seemed to be at odds with what relativity was saying. And we can understand now that it's the both and, but we can only do that by bringing in recent understanding about what we'll continue to talk about, I'm sure, the holographic principle and other aspects of this whole model, that we can realize it's a both and. So that our universe exists and evolves as a unitive, as a non-locally whole entity. So it knows itself. It has spontaneous knowingness of its entirety in every moment from its beginning 13.8 billion years ago. As space has expanded ever since, and as time has flowed forward ever since, it knows itself in its wholeness. And yet, within space-time, there is a cosmic speed limit, which is the speed of light. And that has to be the case. Otherwise, first of all, there wouldn't be that flow of time. Secondly, there wouldn't be the causality that enables our universe to evolve. And so thirdly, we wouldn't be having this conversation. And there's a lot of reasons why the laws of physics require this. But this was the big issue, because Einstein was very unhappy with the idea of universal entanglement. He called it spooky action at a distance. He realized that there was a limit, a finite limit, to signals within space-time. But what he wasn't able to understand, and nor were the quantum physicists of those times, that it's a both and. The wholeness of the universe, and yet within it, it learns about itself because of that innate flow of time and causality that is journeying through its entire evolutionary journey.
Absolutely. And I'm curious as well, as a more targeted question too, because if we have entanglement at macroscopic scales, and that's been empirically shown, how can we also simultaneously not have information transfer faster than the speed of light?
It's really, you need the holographic principle to start to understand that. And the holographic principle came about from studies on black holes. And the question was, at the end of a massive star's life, when it's run out of its nuclear fuel, which was actually stabilizing it, its outward pressure was stabilizing it. When that fuel's used up, the star collapses. Now, if you're a sort of small or medium-sized star, you just keep on going to be a white dwarf or whatever. But if you're a massive star, then the forces are too strong. The gravitational collapse is too strong to stop it. So the star collapses, and it does so three-dimensionally. It does so spherically. It's a spherical star to begin with. It falls in on itself, but a point comes where it passes a threshold where not even light can escape. And so it becomes what's called a black hole. Now, the question then is, what about all the information that was telling the story of that star? Where does that go? Because if it disappears, then quantum mechanics is out the window. It doesn't work. It's just out the window. So there was a big hoo-ha about, well, what does happen? And it was discovered that the information is actually held on that event horizon. Now, this is where it gets a lot of fun, because you'd think that all the information of that three-dimensional spherical star would be proportional to its volume. So the volume of the black hole, would actually be a measure of the information that's retained, but it's not. It's proportional to the surface area of that star, which is the spherical event horizon. Now, when that was realized, and there's a measure of that called the Bekenstein bound and all sorts of stuff, when that was realized, there was an aha moment, because that's what a hologram does. When you shine a beam of light at an object, a 3D object, well, you split the beam, and part of that beam then reflects back off of that object. It brings back the 3D info of that object. When it's mixed with the original beam of light, it then forms a two-dimensional patterning of that information. And then when you shine another beam of light through it, it projects a hologram, which is the three-dimensional appearance of that original object. Yeah? So what cosmologists realized was we could expand, and there are lots of other reasons for saying this is heading in the right direction. We can expand that understanding to a holographic principle, which is a universal principle, that our entire universe, the appearance of our entire universe, is a holographic projection from the boundary of what we call space and time. So here we are, a universe that begins in its most minute form nearly 14 billion years ago, as simple as it could be, but no simpler. And then as space has expanded ever since and time's flowed forward, and we can talk about how that happens. But basically, there's more and more and more and more information able to be expressed within what we call space-time and manifested in as what we call energy, matter.
there are multiple directions I would love to take, and several different questions popping up in my head. But I think the first one I feel that everyone probably will ask is, how do we make sense of physicality? Given
Yeah,
that we are in a holographic universe where information is
yeah,
fundamental, as you
absolutely.
posit, what's the translation from information into physical reality, quote unquote, in asterisks? And
Sure.
I recall as well you mentioning that information is material and energy matter is immaterial, if I have that correct.
It's more that it's both and. And our definition of materiality, of course, as you say, has been based on what's physical. Yeah. When we're sitting in our chairs, we're not falling through our chairs. Yeah. When I, well, occasionally I do. I'm
Thankfully,
really good
yeah.
at falling off chairs. Um, but what I would say is our universe, its manifestation is real. That is real. But when we talk about physicality, we're talking about solidity. Yeah. That's our perception of physicality. We're solid. I can do this and this and all the rest of it. When we go smaller and smaller and smaller, we've realized a long time ago that atoms aren't the sort of little billiard balls of electrons and neutrons and protons and beneath that quarks. What they are relationships of fields, quantum fields, and we're now restating those quantum fields in informational terms. But the reason that reality appears solid is that part of quantum mechanics is that those individual sort of standing waves of those interactions cannot occupy the same quantum state at the same time. And so when we have electrons, they can't occupy the same state at the same time. So there's appearance of separation. Yeah. Added to which, the electrons that whiz round the nuclei of atoms, or the interactions and the relationships that we perceive in that way, have the same charge. And the laws of electromagnetism say that like charges repel. So we have two aspects. We have what's called the Fermi exclusion principle, which says that, quantum entities, certainly those that make up atoms, there's other types that, can occupy the same quantum states, but those that make up what we call normal matter can't occupy the same quantum states at the same time. That's why we get the appearance of separation of physicality. Okay. And I'm not for a moment saying that because our universe is a cosmic hologram, that it's no less real. It's just the way in which universal genius, cosmic mind can co-create such a universe.
So in essence, you would say that it has to do largely or mostly with it was Pauli exclusion principle, or with
Sorry, I
fermions.
do apologize. It was the Pauli exclusion principle. I've had a
Oh,
long
sorry.
day. I
No, you're
apologize.
good. I don't mean to correct you. I'm just making
No,
sure I'm
please
on
do.
target.
Please do. It
So,
was the Pauli exclusion principle.
yeah, I think fermions can't occupy the
That's
same
exactly
quantum
right.
state.
Jared,
Awesome.
thank you for that.
That's a nice little personal chalk for myself. But so really we're really just physically repelling because we can't occupy the same states. It's more of a electromagnetism, if you will, in that sense.
It's a both and, because obviously like charges also repel. So yeah, all the laws of physics are just so exquisitely relational and perfect to actually, enable a universe of quantized energy matter. And I would say non-quantized, but entropic space time, that both are needed. And all the laws are needed to enable our universe to meaningfully exist and purposefully evolve.
Sure. So I think this is a good segue too into the big one, which is wave function collapse,
Yeah.
because we have, objective collapse, we have pilot wave theory, we have quantum Bayesianism, we have, the traditional Copenhagen interpretation. I mean,
Sure.
so I would love to kind of dive in there in informational terms and in holographic terms. How do you perceive wave function collapse? Is there a thing out there? And as you mentioned, does the tree fall? Does it make a sound if no one there is there to hear it? Type of thought process.
Yeah.
What's your general perspective in this framework on wave function collapse?
Well, what I would say is, going back to that analogy of if a tree falls in a forest and there's nobody there to see it, does it actually fall? I would invite us to consider our entire universe is both the observer and the observed. That our entire universe is essentially, a friend of mine is a guy called Max Velmans. He calls it reflective monism. So in other words, the entire universe is aware of all that is happening at all times. And then the individuated self-awareness that includes us is aware of different aspects of that. And yet we are microcosmic co-creators of the entire universe. So that's also why we are naturally enabled with noetic phenomena, noetic experiences, because we are like sort of cells in our universe's body. So when our universe, which continually exists and evolves as a unitive entity, the waveforms is its potentiality. The waveform collapse, which occurs at all scales, not just minute scales, not just is an ongoing Planck scale upwards phenomena that actually is the entire universe existing in its existential entirety. Yeah. So there's no sort of separate waveform. There's differentiated waveform collapse as part of a whole sort of bow wave of the universe's ongoing progression from past into the present and potentizing the future. You know, when you've seen a ship go across a lake, there's a bow wave in front of it. That's the best understanding I think we have at the moment, that there is that potentizing that plays out at all scales within the wholeness of that universal progression that then comes into the particularization of the here and the now.
So it's in the bow wave analogy. Is it something to where it's sort of a universal phenomena that is sort of collapsing reality as we know it? Or do we have some level of entanglement with the whatever what is a measurement? What is this process of going from infinite possibilities to quantization?
Well, first of all, there's no infinities within space-time. Our universe itself is finite. It began a finite time ago. There is no manifestation within space-time that is infinite. I mean, that, if you remember, was what opened the door to quantum physics, because the 19th century view of electromagnetism on a black body radiator would actually have infinite wavelengths. And clearly that's not the case. And that would led to the quantization of energy matter, that then realized that there was finiteness. Everything we actually see and measure within space-time is essentially finite. But what we're saying is, with the hologram, before that finiteness comes into its manifested form, which it does so in each Planck moment from the beginning of our universe all the way through, it's like a shutter speed of our universe. And it's a shutter speed of 10 to the minus 44 seconds. Extraordinary. But it, together with the expansion of space and the Planck scale pixelation of information, which itself is minute at minus 35 meters, 10 to the minus 35 meters, what you get is this potentiality to then manifest in the appearance of what we call our universe. But it does so finitely. And the measuring point is how we measure. And that's, in a sense, it's not a paradox. I talk about parallax because in physics, as you know, parallax is looking at things from a different perspective. So if we look at a particular experiment and measure it from a particular point of parallax, we'll get a particle. If we measure it from a different perspective and parallax, we'll get a wave potentially. But it's both and, because ultimately the universe is both and.
Mm. One last question I have on this topic before we transition to others, just to make the best use of your time here, because there's so much I want to cover in this time here. But the last thing is, I was personally curious, what is the key difference between pixelation and quantization? Because I recall you mentioning...
Yeah.
Go ahead.
Yeah. Yeah. Well, pixelation, I mean, the screen that we're, conversing through is pixelated. It's high definition pixelation. Okay. But nonetheless, the screen has tiny sort of little areas with different information within it that makes up the photo of us. Yeah. That's pixelation. Quantization is where there's quantum is packet. So within energy matter, all energy matter is quantized. In other words, it occurs as packets of information rather than notes of music, rather than a continuous continuation. It's literally quantized in packets. And that is why and how, the materiality of our universe can express itself. Yeah. And it does so very beautifully because of that. So the pixelation of the entirety of the appearance of our universe is pixelated at the Planck scale. And when we scale, that pixelation is all the information of our universe, and it's expressed in complementary ways as quantized energy matter, but it's also expressed as this ongoing journey of space and time, hence the whole evolutionary story. And space-time, I would argue, is not quantized, but all of the appearance comes from this tiny, minute pixelation of all the meaningful information that expresses itself in our universe. And that pixelation, if we look at our high definition, that pixelation scale is a trillion times smaller than our best Ph.D. technology at the moment. It's literally as small as to an atom as an atom is to the whole universe. So the way our universe exists and evolves, it requires these different yet complementary ways of expressing its universal information as quantized energy matter, which enables our universe to exist and express itself, and it's conserved and it changes, but it can't be created or destroyed, so it just changes. And then is as what I call entropic space-time, whereas as space expands and as time has flowed from the beginning, what I call entropy, which is the informational content of our universe, always increases. That enables our universe to evolve. So quantized energy matter and entropic space-time are complementary. They come together to enable our universe both to exist and to evolve. You need both.
That's a wonderful bridge into time. So I'd love so I would love to just kind of open the can on this one about really the paradigm shift of seeing reality, number one, as finite, potentially even toroidal, which is another aspect of what you mentioned, but as this perhaps information bubble that through experience and through its evolution, which we are in and also co-creating, the flow of time itself is literally the entropy of information all the way back from the big breath. And I'd love for you to just kind of lay some fundamentals for, what is time?
Well, I think you've expressed it beautifully, Jared. When we go back to the beginning of our universe, which is finite time ago, it came into being at its smallest state, but also its simplest state. Now, the second law of thermodynamics says that going back to 19th century, that the entropy, which is the energetic microstates of a containered system, can only increase through time. Okay, so if we go back to the beginning of our universe, it was at its lowest entropy. So time could only go one way from that beginning. And that way is from the past all the way through to the present and then to unfold into the future. But what I've done is I've expanded those 3 laws, and there are 3 laws, of thermodynamics to 3 laws of information or infodynamics. And when we do that, we realize why we need 3 laws. And we also realize that if the first law, which in thermodynamics talks about the energy of a container system, can change through time, but it can't be created or destroyed. Apply that to our universe, it applies to the quantized energy matter, which says that information expressed as quantized energy matter can only change through this whole process. It can't be created and destroyed, enabling our universe to exist. But then you get to time and you get to the second law and you get to expanding entropy. And the second law of thermodynamics was all about, in 19th century, about entropy. It said that the entropy of a container system can only increase through time. So talk about our universe, entropy is about energetic microstates. But going back to a point you made earlier, information is as physical as energy, and we can expand, as we've done the first law, into information as energy matter, but we can expand energetic microstates to information content. And it's the same equation. It's the same Boltzmann's equation. So what we can say is the entropy, I-entropy, information content of our universe began at its lowest level. So as time has flowed forward and as space has expanded ever since, that information, that entropy has increased, and that enables, with that flow of time and the expansion of space, for the holographic nature of our universe to manifest more and more experience. And because for me it's a cherry on top of the icing, on top of the cake, the third law of thermodynamics says that the temperature of a container system, like our universe, is inversely proportional to its entropy. So I would say inversely proportional to its entropy. Our universe came into being in its lowest entropy, its lowest entropy, its highest temperature. So space has expanded ever since. Temperature's dropped. As time flows forward ever since, entropy has increased. So it's this beautiful reciprocity that really has driven the universal life cycle. And now it began at 10 to the 32 degrees Kelvin. We're now at 2.73 degrees Kelvin. I would suggest that means we're closer to the end of this thought bubble. I love how you described it. This thought bubble of our universe, to its completion. And I also love that you refer to the big breath, because our universe did not begin in the chaos or the implied chaos that we were taught was the Big Bang. We know it wasn't big, but it wasn't chaotic. It wasn't a bang. And you refer to it, and I call it to the first moment, an ongoing big breath, exquisitely fine-tuned, wonderfully ordered, purposeful, meaningful.
That's so beautiful. And I'm curious if I feel like this is something that you posit as well in the book. Is our universe, our finite universe, one thought bubble in an infinite plenum of thought bubbles, and where it completes, the temperature drops, the entropy is maximized of information.
Yeah.
There's no further complexity to be had, and then from there it is perhaps released into the cosmic plenum. Is this what you'd perceive the process is on the highest level?
Yeah, I do. And then you ask, well, where do baby universes come from?
Right.
And one of the I believe is that the most intriguing suggestions for this is an extension to general relativity, which is called ECKS, which stands for Einstein, Cartan, Kibble, Sharma extension. And Dennis
Nice.
Sharma, who was Stephen Hawking's mentor for his Ph.D., was my mentor. at Oxford.
Oh, wow.
And Dennis loved Mavericks. So I hope he'd be very proud of me by now. But it's an extension whereby it's very, very complex, but in really extreme cases, at the very heart of black holes and possibly even supermassive black holes, there's an extension to general relativity which has a toroidal effect. It's like a screwing effect. And it may be that that is the origin of baby universes that bring with them some of the past story, some of because our universe is so exquisitely fine-tuned. It does suggest it's not the first, it's not its first rodeo, as our American friends say, but there is this sense of heritage and almost like a reincarnation of a potential for greater complexity, that we could actually consider the possibility of being on universal scales.
Even like cosmic epigenetics, if you will.
Yeah, I love that, cosmic epigenetics, and my follow-on book from the Cosmic Hologram was the story of Gaia, and that really tells this story, the whole evolutionary story of us, and our story is the story of our universe. So that story I feel is so empowering, because we can people who I hope read the story of Gaia really come to feel that we belong. We belong here. We have meaning and purpose.
I was profoundly shifted by that section of at least the Cosmic Hologram with the fine tuning. I mean, talk about mind blowing, the different principles and like the different forces that are so unbelievably fine tuned to allow even different elements to emerge. And
Absolutely.
and I'd love for you just to touch on just the sheer fine tuning of the reality in which we live in, the utter impossibility of randomness of what the beauty of this cosmos is.
Absolutely. Well, there are various measures of this. There are around 6 fundamental universal constants. And Martin Rees, who has done a book on this called Six Numbers, basically. But when you look at those and see what would be different if any of them were a tiny stage different from what they actually are, and it works out something like 1 in 10 to the 27. I think Lee Smolin came up with that figure, but it's 1,000 trillion times 1 to 1,000 trillion. I mean, as you say, it is mind-boggling. But when you look at the laws of physics, I mean, if you don't understand that mind and consciousness aren't what we have, they're literally what we and the whole world are. Quantum physics is a mystery. But when you do understand that it's a way in which the potentiality of consciousness can express itself and manifest itself, it is very straightforward. And what we find as well in the basic laws of physics, they are incredibly simple. E equals mc squared. E equals h nu. Gravity. F equals gm1 m2 over r squared. These are not rafts of equations. They're incredibly simple. And the reason that they are so simple, or able to be so simple, is because that exquisite fine tuning. With electromagnetism, we've now measured space to be it has to be flat. Because first of all, otherwise electromagnetism could not work in its orthogonality. In other words, a magnetic field goes one way, the electromagnetic field is 90 degrees to it, and the light goes 90 degrees to that. Exactly. Not a bit of a fudge. When we are taught, geometry at school, we learn Pythagoras, we learn about triangles, and we learn about the 180 degrees, and we learn about, the relationships between the sides of triangles. There's a very straightforward way of taking that space, Euclidean space, of a triangle with 180 degrees, which is on flat paper, because if we curve the paper, a triangle has more or less than 180 degrees, but on flat paper, a triangle has internal angles, the total 180 degrees. There's a way of moving that into what's called Hilbert space, which is a sort of slightly more sophisticated way of working with space to understand the relationships of energy and matter. And you can go from Pythagoras to Einstein. E equals mc squared. E equals mc squared only if space is flat. Only if space is flat. And the final thing, and this is the big giveaway as well, is throughout quantum mechanics and also relativity, but quantum mechanics is the biggie. Schrödinger wave equation and all of the equations are pervaded by, and holographic principle is pervaded by something called I, the square root of -1. And that we're realizing is not just a mathematical nicety. It really is the foundation between the appearance of what we call our universe and its underlying causation. It's cause they literally, it arises from what some folks call phase space. But that is that not yet manifest, you were talking earlier, not yet manifest realms of causation that then come into the manifest universe. And so I, the square root of -1, is that sort of mathematical mode by which that transfer, that progression from what we might call immaterial to material actually takes place. So all of these hand together beautifully, but only if, if they share all of these features.
Wow. And that's a perfect segue to the idea of fractals, which I have been very excited to talk about. But in terms of the complex plane, and as you pointed out, the Schrödinger wave function should go on infinitely, but we know the universe is finite. Also, from looking at the cosmic microwave background, there is a limit on the wavelengths, as you pointed out. And so we know there is a finiteness to it, but yet obviously that's not what we experience in finite reality. So there's that translation from the complex, as you said, the potentiality, the immaterial or super physical to the physical, always an asterisk. But
exactly, and that ultimately the infinite and eternal cosmic plenum to that finiteness of this thought bubble we call our universe.
I love that, and so. When it comes to fractals, one thing I was wondering about is the law of attraction, because as you talk about fractal attractors and even precognition and supernormal phenomena of sort of being able to non-locally perceive information as it's sort of crystallizing perhaps in the complex plane, before it becomes potentializes into physical reality. Do you think there's any connection there between the law of attraction and kind of what you put out and what you're able to actually crystallize and potentiate into reality?
I would, and I wouldn't sort of oversell it either. I mean, the laws of physics are the laws of physics. I might have the intention that I'm going to become the hang gliding champion of the world. It ain't going to happen, Jared. I have to tell you this.
Sure.
Okay. But yes, indeed, because we are microcosmic co-creators of the macrocosmic sentience of our universe. And therefore we do have natural attributes of awareness that are non-local in that regard. But just to go back to your point on fractals, for those folks who are listening to us that aren't sure what a fractal is, it's basically a relationship. And in the ancient Greek geometers, were wonderful in the fact they had something to write with and something to create a straight line with, and they intuited profound truths about the innate relationships of our world. And so when we look at the Platonic solids, and when we look, they're essentially idealized fractals, and fractals are realistic Platonic solids in that regard. In other words, when we look at a cloud, we're not seeing a triangle, but if we actually analyze the outline of a cloud, we can actually subdivide triangles into more and more and more and more and more detail, and they are fractals. Or we can take fractals to their endpoint idealism, and we end up with a triangle. I mean, that's very straightforward, but what it's showing is that the entirety of our universe plays out innately through relationships and interdependent relationships. And the point about a fractal, just as it does for a triangle, it scales up and it scales down. So when we look at the evidence of the cosmic hologram, we see it at all scales of existence because we're seeing fractals at all scales of existence. When a metal atom is moving to become an insulator or vice versa, its electrons cluster fractally. We can see fractals all the way up to planetary systems. We see them in the solar wind and planetary orbits. We see them galactically. We see the same fractal relationships, as you mentioned, in the cosmic microwave background, in the temperature differences there. So we're seeing them all the way up and all the way down. And they are indicative also of Fourier transforms. And Fourier transforms are a mathematical bridge that actually underpins the holographic technologies. So we're seeing so many things pointing in the same direction and across numerous fields of research. So underlying complex systems, whether it be an ecosystem or the internet, are the same fractal patterns. We're seeing the same power law relationships between frequencies of phenomena and their scale that we do earthquakes and conflicts and human conflicts. So what we're seeing throughout not just natural systems, but human choices, collective human choice and behaviors, is this underlying causation and the all-pervasiveness of consciousness. So going back to the law of attraction, we're essentially playing out conflicts in the world because we have a worldview of separation collectively. We have a dis-ease of separation. We can create, if we've got an attractor pattern, and the laws of attraction in that sense are we're behaving in conflictual ways, in inequitable ways. We can create an attractor pattern for love, an attractor pattern for peace. So
That's
and
beautiful.
that for me is our choice now. Do we stay in this old worldview of separation and fall into fear, or do we, as I truly believe we have the capacity to, and the invitation from the universe to, literally leap into love and undertake a conscious evolution that I feel is our opportunity, our invitation, and the reason we're here.
Absolutely. And people just like you are providing the evidence so we can all really see, I think, through the rational mind, I think is really the key. I think that's what's going to make this so accessible, is even talking about fractals. I mean, that's a slam dunk to holographic principle. I mean, it's self-similar. I mean, the whole is contained in the part, and
Exactly.
the fractality of reality is so obvious just from the evidence that you've put forward alone. And I had one other question to follow that up here is, what does this say about free will? And more specifically, with Benford's law and Zipf's law, where we have fractal patterns for, I wrote a few things here, such as Twitter users to follower ratios, street addresses, corporate sales versus costs, stock prices, population densities, galaxy formations, and even to the words we say follow these numerical patterns. And it almost feels like one big mind playing itself out. But what does that say about free will if it's that codable, our behavior through the internet, through stock markets, whatever it might be?
Sure.
What does that indicate about our individual choice?
It's interesting. I'm a both and person. Whenever it's an either or choice, I go, what am I missing here? And just as now we can say that, relativity physics and quantum physics are complementary. Energy, matter, and space-time are complementary. We need both and. I would say that collectively, all our choices together form Zipf's law. They form all of the phenomena that you identified. But the entirety of our universe, the wholeness, and this is the beauty of it, is also playing out through each of us. And so in that sense, my view is that we do have free will, but not in the complete sense of being separable. We are inseparable, and yet we are unique expressions. And we are self-aware, individuated, microcosmic co-creators. Yeah? But when we come together, then that totality, because we're working at so many levels of consciousness, Jared. And when we talk about free will, it's not just the level that we're aware of, it's that subliminal level. So a lot of our choices are also at that subliminal level. And I think it's primarily those choices that we can see playing out in these collectives. So I think it's a both and. The question I would ask is, what are we choosing at the moment? Are we choosing fear or are we choosing love? And I would suggest that we have a free will choice in that regard. And on a personal level, I choose love. I would also say that the evidence we have, because of its wholeness and its inseparability and yet its differentiation and its meaning, existential meaning and evolutionary purpose, is I describe our universe not just as a living universe, but as a loving universe.
Oh, I love that. And I think that's a lovely way to conclude our conversation. And before we do so, because I know we're coming up on time here, is I would love to give the audience just a couple minutes here if you want to share where they can find you, such as maybe a couple of your books, maybe if you have a website you want to share, and I'll drop everything in the description as well.
Oh, that's so kind of you. I think the easiest thing is just to offer a website, which is www.whole, W-H-O-L-E, world, W-O-R-L-D, -view, VIEW.org. And on that, we've got links to my books. We've got lots and lots of free resources around everything and unitive science and all of this. We've also got a link to a recent film, which is called A Radical Guide to Reality, which is 14 minutes long. It's free to view and free to share on YouTube. And it's in 19 languages at the moment, from Arabic to Ukrainian. And we're just adding another one, Bengali. So,
Wow.
and more. So, but it, and we also on the website, we have an educational wraparound. So glossary of terms and things like that, and invited experiences. So there's a whole range to, and an invitation to come home and come to this adventure.
That's so amazing. Thank you so much, Jude, for all of your wisdom and your time today. It's been an absolute pleasure, and maybe perhaps need a round two, because I still have a lot of questions. But
I would
I'm
love round two. I would love round two. And maybe on
Wonderful.
round two, we could talk about the story of Gaia, because when we talk
Yes.
about the evolutionary story, I mean, you talked about blowing your mind. My goodness me, that takes it to a whole next level.
Yes, I would love to, and talk about panspermia and all of that stuff. So
All
yes.
of that stuff.
Yes, awesome, Jude. We'll talk offline about that. I want to get you on to your next meeting here, but thank you so much again, Jude, and have a fantastic rest of your day.
Oh, bless you, Jared. Thank you so, so much, my dear.
All right, take care. Bye-bye.
And you. Bye-bye.
Thank you for tuning in to this episode of the Quantum Theory Podcast. If you desire to embark on the path of self-mastery, visit quantumtheorypodcast.com to join a like-minded community of purpose seekers committed to personal growth.